The 2026 USS Zumwalt DDG 1000 destroyer represents one of the most advanced and unconventional surface warships ever built for the United States Navy, and even years after its commissioning it continues to draw attention for its futuristic design, evolving weapons systems, and unique role in modern naval warfare. When people first see USS Zumwalt DDG 1000, it does not resemble the traditional image of a destroyer at all. Instead of sharp angular decks filled with visible missile launchers and radar domes, it looks closer to a stealth spaceship placed on water. That unusual appearance is not accidental, it is the result of decades of engineering aimed at reducing radar visibility, increasing survivability, and preparing the ship for highly networked, high-tech warfare in the 21st century. At the core of the Zumwalt's design philosophy is stealth. Unlike older destroyers that reflect radar signals strongly due to vertical surfaces and exposed weapon systems, the Zumwalt uses a tumble-home hull design, where the ship's sides slope inward rather than outward. This, combined with a faceted superstructure, dramatically reduces its radar cross-section. In practical terms, this means that on enemy radar screens, the ship can appear more like a small fishing vessel than a 15,000-ton guided missile destroyer. The entire exterior was designed with radar absorption and deflection in mind, making it one of the most stealth-optimized surface combatants ever constructed. However, stealth is only one part of the Zumwalt's identity. Another defining feature is its integrated power system, which is often described as the ship's electrical backbone. Instead of relying on traditional mechanical propulsion systems that directly connect engines to propellers, the Zumwalt uses an all-electric architecture. Its gas turbine generators produce electrical power not only for propulsion but also for onboard systems, sensors, weapons, and future high-energy weapons. This design provides enormous flexibility, allowing engineers to distribute power wherever it is needed most at any given moment. It also opens the door for future upgrades such as directed energy weapons, railguns, or advanced electronic warfare systems, even though some of those original ambitions have been scaled back or delayed. Propulsion-wise, the ship is powered by Rolls-Royce MT-30 gas turbines combined with additional smaller turbine generators. These feed electricity into advanced induction motors that turn the propellers. This system allows the ship to reach speeds of over 30 knots despite its large size, while also maintaining a quieter acoustic signature compared to conventional mechanical propulsion systems. Reduced noise is particularly important for avoiding detection by submarines, giving the Zumwalt a tactical advantage in underwater threat environments. One of the most striking aspects of the Zumwalt class is its emphasis on automation and reduced crew size. Despite being significantly larger than the Arleigh-Burke-class destroyers, the Zumwalt operates with a crew of roughly 140 sailors, compared to over 300 on older ships. This reduction is made possible by extensive automation in engineering systems, damage control monitoring, and combat systems management. Everything from machinery diagnostics to fire suppression systems is heavily automated and centrally monitored. This not only reduces manpower requirements but also changes the entire lifestyle and workflow aboard the ship, making it more technologically dependent but operationally efficient. The combat system architecture onboard is equally advanced. The Zumwalt uses the Total Ship Computing Environment, which integrates all combat, sensor, and navigation systems into a unified digital network. Instead of isolated systems operating independently, everything is connected through high-speed data networks. This allows for faster decision-making, improved situational awareness, and better coordination between weapons and sensors. The ship's radar system, known as the AN/SPY-3 multi-function radar, is a highly sophisticated active electronically scanned array system capable of tracking multiple airborne and surface threats simultaneously, even in dense electronic warfare environments. Originally, the Zumwalt was designed with a strong focus on naval gunfire support for land operations. It featured two advanced gun systems AGS intended to fire long-range precision-guided artillery shells. However, due to the extremely high cost and limited availability of compatible ammunition, these guns became largely impractical for their original mission. As a result, in the 2020s and leading into 2026, the Navy began repurposing the Zumwalt class for a more modern strategic role, serving as a platform for hypersonic missiles. This transition is one of the most important developments in the ship's evolution. The original AGS turrets are being replaced with Vertical Launch System (VLS) modules designed to accommodate the conventional Prompt Strike (CPS) hypersonic missile system. These missiles are expected to travel at speeds exceeding Mach 5, with the ability to strike high-value targets at extremely long ranges within minutes. This transforms the Zumwalt from a specialized shore bombardment ship into a strategic deep strike platform capable of engaging time-sensitive targets such as enemy missile batteries, command centers, or naval formations. The shift to hypersonic weapons also aligns with broader changes in naval warfare strategy. Modern naval combat is no longer just about ship-to-ship engagements, it is about networked warfare, rapid precision strikes, and dominance across multiple domains including sea, air, space, and cyber. The Zumwalt is designed to operate as a node within this larger network, sharing sensor data with satellites, drones, submarines, and other surface ships to create a real-time battlefield picture. In terms of design aesthetics, the Zumwalt is often described as both intimidating and elegant. Its angular surfaces, enclosed deck, and lack of traditional clutter give it a futuristic silhouette. The bridge is positioned deep within the superstructure, providing protection from detection and attack. Even lifeboats, antennas, and deck equipment are carefully integrated into the hull to avoid breaking the stealth profile. Every inch of the ship is designed with radar signature management in mind. Another unique selling point of the Zumwalt is its survivability systems. The ship is divided into multiple isolated compartments, each with redundant systems for power, fire suppression, and damage control. In the event of combat damage, the ship is designed to isolate affected areas while maintaining operational capability. Combined with advanced sensors that constantly monitor structural integrity, the ship can react quickly to internal or external damage scenarios, improving crew safety and mission endurance. Living conditions onboard also reflect the modernized approach to naval design. Compared to older destroyers, the Zumwalt provides more comfortable accommodations, improved climate control, and quieter internal environments due to its electric propulsion system. The reduced crew size also means less congestion and more efficient use of space, allowing sailors to operate in a more streamlined environment during long deployments. Despite its technological achievements, the Zumwalt program has also faced criticism over its cost and changing mission profile. Originally envisioned as a multi-role land attack destroyer with revolutionary fire support capabilities, it evolved into a smaller class of ships than initially planned, with only 3 units completed. However, instead of being seen as a failure, the ship is increasingly viewed as a technology demonstrator and a bridge to the future of naval warfare. Many of its systems, especially its integrated power architecture and stealth shaping techniques, are influencing the design of newer ship classes. By 2026, the Zumwalt is not just a warship but a testbed for future naval innovation. Its role continues to evolve as the U.S. Navy explores new ways to integrate unmanned systems, hypersonic weapons, and advanced sensor fusion technologies. There is growing interest in using the ship as a command and control hub for drone swarms, both surface and aerial, expanding its influence far beyond traditional naval gunfire or missile roles. Operationally, the Zumwalt is designed for flexibility in contested environments. Whether operating independently or as part of a carrier strike group, it can perform reconnaissance, strike missions, electronic warfare support, and area denial operations. Its stealth capabilities allow it to approach closer to hostile shores or naval formations than conventional ships, giving it a tactical edge in early engagement scenarios. From a broader